Hello everyone, this is Sir Marvin. So today for statics of rigid bodies, we're going to discuss the second lesson, which is the resultant of concurrent force system. So for this topic, the learning outcomes would be students must be able to compute the resultant of concurrent force systems. And the second one is to locate and draw the resultant of concurrent force system. So let's start with the resultant of two concurrent forces. So let's say we have a force system and there are two concurrent forces. So we can actually use the axiom that we have discussed on the previous topic. So which is the parallelogram law. So the parallelogram law states that the resultant of two forces is the diagonal of the parallelogram form on the vectors of these forces. So since we are talking about two forces here, okay, so we can apply parallelogram law. Okay, so let's say we have two forces. Okay, so as I've mentioned in the previous discussion, if you have two forces, let's say this force and this force, and if we offset these forces, let's say the offset of this force is this one and this one. Okay, so it formed a parallelogram. Now, the diagonal of this parallelogram, which is this one, this will be the resultant of these two forces. Okay? Okay, so now let's talk about triangle law. So the concept of triangle law actually came from the concept of parallelogram law. Okay, so it can be used to compute resultant of force systems with two concurrent forces. So we can use triangle law, okay, for that, for solving that. So if two forces are represented by their free vectors placed tip to tail, their resultant vector is the third side of the triangle. The direction of the resultant being from the tail of the first vector to the tip of the last vector. So let's say we have here two forces. Okay, so this force and this force. So we can solve these two forces, okay, we can solve its resultant, okay, by using triangle law. So what we're going to do here is that we have to redraw these forces in such a way that we can create a triangle. So the manner of creating the triangle, okay, should be should be by placing these vectors from tip to tail as mentioned here. Okay, so either of these two forces can be drawn as the first vector. Okay, so let's say we choose this vector or this force as the first vector to be drawn. So we draw it this way. Okay, so the same way it was drawn here, it should be the same way also that we're going to draw it in our triangle. Okay, so it will be the same inclination from the horizontal. So if it's inclined this way, if you draw it for your triangle, so it should also be the same inclination. Now, what you're going to do to connect the second vector is by placing this vector from the tip of the first vector. So the tip of the first vector is this point, right? And then the tail of the second vector is this point. So we have to connect that, okay, again from the tail or from the tip of the first vector to the tail of the second vector. So we connect it that way. Now, for your resultant, it will be the third side of the triangle. So to form a triangle, we have to put aside, okay, here from this point to this point. So that side will be the resultant. Now, as mentioned here, the direction of this resultant, okay, will be from the tail of the first vector. So the first vector again is this vector. So its tail is this point, okay? And then the to the tip of the last vector. So our last vector is this vector. So its tip is this way. So again, the direction of the resultant will be from the tail of the first vector to the tip of the last vector. So this will be the resultant. This side will be the resultant. And also class, we can actually choose also this side of or this force, okay, as the first vector to be drawn for your triangle. Pwede din. So it can be drawn as the first vector as well. But you have to connect the second vector, okay, by placing that vector from the tip of the first vector to the tail of that second vector. So it should be drawn this way. So it should also be drawn, okay, the same way, the same inclination as the original given. Okay, so it also, this is drawn horizontally, so it should also be drawn horizontally in your triangle. And then connecting the second vector, and then the third side or the third vector will be your resultant, and it will give you the same direction from, again, from the uh, tail of the first vector to the tip of the last vector. That will be the direction of your resultant. And as you can notice, this resultants, okay, is just the same, okay, regardless of what is the first vector that was drawn, right? Regardless of what vector is drawn first and what vector is drawn second, right? So it will give you the same resultant. Okay, and also this is the same resultant when you are using parallelogram law. Okay, so for your parallelogram law, this is the diagonal side of, or the diagonal of your parallelogram, right? So it's the same side. Okay, so it will give you the same resultant. Okay, so after forming the triangle, we can now solve for the resultant by using the laws of triangle. So on the succeeding slides, we're going to recall the laws of triangle that we can use to solve for the resultant of two concurrent force system. Okay, so the resultant of two force concurrent force system must include the resulting magnitude, direction, angle from the horizontal. So these are the important parts, okay, when you are asked to give the resultant, it should include the magnitude of the resultant, okay, the direction of the resultant, and the angle from the horizontal of your resultant. Okay, so we're going to talk about how to solve this, okay, on our succeeding slides. So this is the first law that we're going to recall for the laws of triangle. Okay, so we can use this, okay, for solving your triangles. Okay, so this is SOHCAHTOA. So this is applicable for right triangles. Okay, for triangles that have 90-degree angle here. Okay, so let's say you have this right triangle. Okay, so this is 90 degrees, of course. And then let's say you have this angle theta here. Okay, so if your angle theta is here, okay, so this side of the triangle, okay, this is called the opposite side. Okay, so this is the side opposite to your angle. That's why it's called opposite side of the triangle. Okay, and this side, this is called the adjacent side because this is the side that is adjacent to the angle. Okay, so this is the adjacent side. And then this side, okay, so this is the longest side of the triangle, and it is called hypotenuse, right? So if we're going to solve for sine theta, so we can use SO for that. So SO stands for opposite for O, and H for hypotenuse. Of course, S stands for sine. Okay, so solving for sine theta, that will just be SO. Meaning it will be opposite over hypotenuse. So it will be the opposite side of the triangle over the hypotenuse side of the triangle. Now, if you're going to solve for cosine theta, so that is ka. Okay, so we will use ka. C stands for cosine, A stands for adjacent, and H stands for hypotenuse. So cosine theta will just be equal to adjacent over hypotenuse side of the triangle. Now for tangent theta, this is TOA. So T stands for tangent, O stands for opposite side, and A stands for adjacent side. So that will just be tangent theta is equal to opposite over adjacent. So we can use this law, ha? Okay. So next. So this is the next law that we can use for solving triangles. No? So we can use cosine law. So cosine law, let's say you have a triangle. Okay, this is not a right triangle, ha. Okay, so let's say you have a triangle and you have sides A, B, and C, and you have angles A, B, and C. So the angles are, let's say this is the side A. Okay, so the angle that is opposite to this side will be the angle A. Okay, and also if this is side B, okay, so the angle that is opposite to this side will be the angle B. And also for this, if this is the side C, okay, so the angle opposite to that will be the angle C. Okay, so we can use cosine law. So this is the formula for cosine laws. Let's say you'd like to solve for A. Okay, for this side A, so you can use A squared is equal to B squared plus C squared minus 2 B times C times cosine A. Okay, so the side that you are trying to solve here, okay, as you can see, the angle that you're going to put here in cosine will be the opposite side. Okay, will be the opposite or the opposite angle rather of this side. So this is side A. So the angle that you should put here in cosine should be the opposite angle. Okay, so opposite to the side A. Okay, and also it's the same for B squared is equal to A squared plus C squared minus 2AC cosine B. So it's the angle opposite to the side that you are trying to solve here. It's the same for this side, no, C squared is equal to A squared plus B squared minus 2AB cosine C. So you can use this, no? So it depends on the given, okay, on the available given, okay, in your problem, okay. And also you can also use sine law. So sine law, you can use this, okay, by using this formula. So this is A over sine A is equal to B over sine B, and that is also equal to C over sine C. So this side, so A, okay, this side of the triangle over the sine of the angle opposite to that side, okay, will just be equal to this side of the triangle over the angle, okay, opposite to that side, okay, kung ano tong nasa numerator natin na side, okay, so it should, the angle in the denominator should be the angle opposite to that side. So it's the same here. No? So we can use also this sine law depending on the available given. Okay, so now let's proceed. Okay, so let's solve our first problem. So the question here is we have to determine the resultant using triangle law. Okay, so let's say you have this concurrent force system and we have two forces here. This 100 Newton force, 50 degrees from the horizontal, and we have this 250 Newton force. This is 20 degrees from the horizontal. So we can use triangle law for this since this is concurrent forces that have two forces. Okay, so let's start solving this. So to solve this problem, the first thing that you have to do is to list down, okay, what is being asked, okay, in the problem. So what is being asked in the problem is to find the resultant. So you write that first, okay, and the second thing that you have to do is to write the given. So the illustration actually, or the figure given is actually the given. Okay, so from here, okay, we can start analyzing the problem. So we're going to solve this using triangle law. So what we're going to do to solve this using triangle law is to form a triangle out of these two forces, right? So it should be drawn, okay, in a tip to tail fashion. Okay, so let's start this, no, by choosing the first vector. So let's say we choose 250 Newton as the first vector. So we have to draw that this way. So if it's drawn here, 20 degrees from the horizontal, it should also be drawn here, 250 degrees from the horizontal. And after that, you connect the second vector from the tip of the first vector, okay, to the tail of the second vector. So we draw the first, the 100 Newton force here, okay, this way. So if it's drawn here 50 degrees from the horizontal, it should also be drawn here 50 degrees from the horizontal. So this is your second vector, 100 Newton. Okay, and this is 50 degrees from here. Okay, now the third side of this triangle, okay, will be your resultant. So this will be your resultant, and it will be drawn from the direction from tip, okay, or from the tail of the first vector to the tip of the second vector. So its direction will be this way. So from here, we can actually say that the direction of your resultant is downward to the left, right? So this will be your resultant. Okay, now we're going to analyze the triangle form. So this is the triangle formed. Okay, so if this is 20 degrees from the horizontal, okay, so from here, okay, from this horizontal, this is also 20 degrees, right? Okay, so this is also 20 degrees, and your 100 Newton, this is 50 degrees from the horizontal. So adding up 20 degrees and 50 degrees, so this will be the angle of this angle, right? Okay, that will be the value of the angle of this. Okay, so redrawing that, so that will just be 20 degrees plus 50 degrees, so that will be 70 degrees. Now, from this triangle, we have side 250 Newton. We have this side, which is 100 Newton. And this is an unknown side, which is R, resultant R, and we have here 70 degrees. Okay, so what we're looking here is the value or the magnitude of the resultant. So we can solve this, okay, using cosine law. Okay, since this is what we are trying to solve, your resultant R, and you have this given 70 degrees here. Okay, so we can use cosine law. Okay, so using cosine law, this will be the formula. That will be R squared is equal to 250 squared. Okay, this is this side of the triangle, and then 100 squared, so that is the remaining side, which is 100 nga. Okay, that will be 100 squared minus 2AB, okay, or your sides, okay, that you have written here, so that will be 250 and 100 times cosine of the angle, okay, that is opposite to this side that you are trying to solve. So the angle that is opposite to this side is 70 degrees. So that will be cosine 70 degrees. So solving for r squared, that will be 55,398.99. Okay, and solving for r, that will give you 235.37 Newton. So try to input it in your calculator right now so that you can check if this is the right answer. So 250 squared plus 100 squared minus 2 times 250 times 100 times cosine 70. So it will give you 55,398.99. So square root that answer. Okay, so it will give you 235.37 to solve for the value of R. Okay, so this is now the magnitude of your resultant R. Okay, and you know that the direction of your resultant is downward to the left. So you write it this way. So this is the direction, and this is the magnitude of your resultant. Now we are also looking for the remaining part of your answer for resultant. Again, the part, okay, that you have to give, okay, if you are being asked to give the resultant, you have to give the magnitude of the resultant, which is this one. You have to give the direction rather. So this is the direction. And lastly, you have to give the inclination, okay, or the angle of the resultant from the horizontal. So in this case, since this is our resultant R, okay, so we have to give the theta x. Okay, so our theta x will be drawn from the horizontal. So this is the horizontal axis. Also, it should be drawn from here to this side. So we have to, excuse me, to find out, okay, this angle. Okay, so this angle, so as uh, drawn here. Okay, so the angle of the horizon of the resultant, okay, from the horizontal will be this 20 degrees plus this angle. Okay, this angle alpha. So that will be your theta x. Okay, so that again, that's the angle of inclination of your resultant from the horizontal. So that will be your theta x. So your theta x will be 20 degrees plus this alpha. Okay, so this is an angle from your triangle, right? This alpha. So how are we going to solve this alpha? So from the given, okay, that are available, okay, we have here the side of the triangle R. Okay, so it is now available. This is 235.37 Newton. And also, we have here 250 Newton side, 100 Newton side. We have here 70 degrees angle. So we can actually use sine law, okay, based on this available given, right? So we can use sine law. So using sine law, we can use the formula. So let's first write the given side. Let's say this side. So this is 235.37 Newton. And the angle, okay, that is opposite to this side, which is 70 degrees. So that will be over sine 70 degrees equal to, okay, so what angle do we want to solve? This angle alpha, no? So the side that we need here is the side that is opposite to this angle. So the side that is opposite to this angle is 100 Newton. So you write 100 Newton over sine of the angle opposite to the side that you wrote, which is alpha. So that will be sine alpha. So from here, we can solve the value of alpha. So we just cross multiply this. So sine alpha, so cross multiply here, equals 100 times cross multiply natin yung sine 70 degrees. So that will be 100 sine 70 degrees over 235.37. So we just cross multiply that. How in this case we interchange sine alpha and 235.37. So you can do that, no? And then we cross multiply sine 70 degrees to 100 just to bring your alpha, okay, at the left side, okay, alone at the left side to solve for it. Now, after having this equation, okay, you can now solve for alpha, okay, by putting this 100 sine 70 degrees over 235.37 inside your arc sine. Okay, so the value of 100 sine 70 degrees over 235.37, if you input that to your calculator, again, 100 sine 70 degrees over 235.37, so that will give you 0.39924. So this is the answer. Okay, so you solve for its arc sine, okay, to solve for the angle alpha. So your angle alpha will be equal to, so solving arc sine of 0.39924, that will give you 23.53 degrees. Okay, so this will be your alpha now. So now, after solving your alpha, you can now solve the angle, okay, of the inclination, okay, of your resultant. So that will be theta x equal to 20 degrees plus alpha, which is 23.50 degrees. So that will give you 43.53 degrees. Okay, so now that will be the theta x. And also, okay, after you solve what is being asked, okay, or what are being asked in the question, you also have to validate, okay, your solution and your answer. Is your answer logical? So in this case, I think this theta x fits the angle, okay, or the drawing here, right? So logically speaking, so it can be acceptable and valid. Okay, so this will now be the answers, your the magnitude of your resultant, the direction of your resultant, and the theta x. So these are the answers now for this problem. So let's solve sample problem number 2. So the vertical force P of magnitude 100 kilonewton is applied to the frame shown in figure A. Resolve P into components that are parallel to the members AB and AC of the truss. Okay, so for this problem, okay, so actually the given is a force P. Okay, so this force P is actually the resultant, okay, given for this problem. Okay, so we have to resolve P, okay, that resultant into its components. Okay, so those components that are parallel to the members AB, so this is member AB and this member AC. Okay, so let's just recall some things, no, about triangle law. Okay, so in your triangle law, you first draw the first and the second vector, right? So those forces are the component forces. Okay, so those forces are the forces that make up the resultant. Okay, so the first two vectors, okay, or the first two forces that you are drawing in your triangle, that is the component forces. Okay, and we are trying to solve for the third side, which is the resultant. Now, here in sample problem number 2, okay, the given here is resultant. And what we're going to solve are the components of that resultant. So we will solve this backwards. Okay, so the given here is the resultant, which is 100 kilonewton. So, excuse me, let us solve this problem. Okay, so let's solve this. So the first thing that you have to do is to list down what are being asked in the problem. Okay, so what are being asked in the problem is to solve for AB and AC, which are the component forces of the given resultant. So the given resultant is 100 kilonewton, which is the force P. Okay, so as mentioned in the problem, okay, your component forces, which are AB and AC, are actually parallel, okay, or have the same inclination or direction as your AB, as your member AB, which is this one. This is 70 degrees from the vertical, and your AC, which is 35 degrees from your vertical or from the vertical. So from that, Okay, let's start solving this. Okay, so we're going to use again a triangle law to solve this. But the thing here is that the resultant is the given. Okay, so we have two options actually how to draw this. So the first one is this one. So you have to draw first, let's say your resultant, no? So this is your resultant, and the direction of your resultant is this way. Okay, so you have to write the first two vectors. Okay, so let's say your first vector is your AB. So you have to write it, okay, this way. Okay, from this from the tip, okay, of your resultant, because the direction, again, as you recall, okay, the direction of your resultant, okay, is from the tip of your first vector, okay, to that, or from the tail of the first vector to the tip of the second vector. So your first vector should be placed from the tail of your resultant, okay, because that's how you write it, okay, using triangle law. So after writing this first vector, which is AB, and this is also 70 degrees from the vertical, so this is also 70 degrees from here. Okay, now you have to draw the second vector, which is this member AC. So this member AC, it should be written from, or drawn from, the tip, okay, of the first vector to the tail of this second vector, which should be this way. Okay, and it should be drawn, okay, to the tip, or its direction will be from the tip of your first vector, okay, to the tip of your resultant, right? Okay, so this will be the direction of your component force AC. Okay, so now you can actually draw it also this way. Okay, so you write first the resultant, and then you draw first your member AC, your component force AC this way, and then you draw the next vector, which is AB, this way. So it will just be the same, no? So as you can notice, it's just the same. Okay, so now let's try to analyze the triangle form. So let's consider this triangle. So from here, as we know, your member AB, or your force AB, okay, so this is 70 degrees from the vertical. So if you put a vertical line here, okay, so this is 70 degrees. Okay, so if you have 70 degrees here, okay, and this is actually a straight line, right? So this is a straight line. So if this is 70 degrees, so the remaining angle here will just be 180 degrees minus 70 degrees, which is 110 degrees. So this angle, okay, is actually 110 degrees. Now, for your member AC, or for your force AC, so this is 35 degrees from the vertical. So this will also be 35 degrees from the vertical. So this is the vertical side. Okay, so this is 35 degrees. So knowing that this is 35 degrees and this is 110 degrees, since this is a triangle, so this should, the angle should be 180 degrees in total. So that will just be 180 degrees minus 110 degrees minus 35 degrees. So that will give you the remaining angle, which is 35 degrees. So this is the angle. Okay, the remaining angle will be 35 degrees. Okay, now from here, since we have all the angles, okay, we have angle 35 degrees, 110 degrees, 35 degrees, and we have here one side given. Okay, so we can actually solve what are being asked, okay, which are the force AC and the component force AB. So we can solve them by using, what law can we use this here, class? What law can we use here? So we can actually use sine law, right? So using sine law, okay, so let's say we want to solve first for AB. So we write first what is available, what is the available data. So that will be 100 Newton. So this is the side of the triangle, 100 Newton. Okay, and the angle opposite to this side is 35 degrees. So you write that. That will be over sine of that angle, 35 degrees, equal to the side that you want to solve, which is AB. So write that, okay, your side AB over sine of the angle, okay, opposite to that side. So the angle opposite to this side is 35 degrees also. So you write 35 degrees here. So solving for AB, so cross multiplying this, okay, so this will be AB is equal to sine 35 times 100. We cross multiply that. That's why it became 100 sine 35 over, okay, sine 35. Okay, so sine 35 here remains. Okay, so that AB will remain here in this side alone. Okay, so that we can solve for that. Okay, so inputting this on your calculator. So let's input 100 sine 35 over sine 35. Of course, sine 35 will just be canceled pala dito. So AB, okay, will just be 100. Okay, so the value of AB will be 100. So also class, don't forget to include the unit. So the unit for this is kilonewton ha. So don't ever forget, okay, to put the unit, okay, of your answer, because if there's no unit, okay, it will not be given a credit, okay, for that. Okay, that will be wrong. So it's important that you don't forget to put the unit of your answer. So the answer for this is 100 kilonewton. So that will be the answer for AB. Now for the remaining side, which is the side AC, or the component force AC, we can also use sine law to solve that. So using the same side, 100 over sine 35 is equal to the side that you want to solve, which is AC, over sine of the angle that is opposite to the side that you want to solve, which is 110 degrees. So this is the side, or the angle that is opposite to the side that you want to solve. So that is 110 degrees. So again, solving for AC, we just cross multiply sine 110 to 100. So that will be 100 sine 110 degrees over sine 35. So inputting that on your calculator. So again, that will be 100 sine 110 degrees over sine 35. So that will give you 163.83 kilonewton. Again, don't forget to put the unit for this. So the answer for AC is 163.83 kilonewton. So now, that these are the answers that are being asked, okay, in the problem. So this is AB is equal to 100 kilonewton, and your AC is 163.83 kilonewton. Okay, next problem tayo. So let's solve now sample problem number 3. Resolve the 360-pound force into components along the cables AB and AC. Use alpha is equal to 55 degrees and beta is equal to 30 degrees. So this problem is similar, okay, to the sample problem number 2 that we have solved. Okay, so the given here is 360-pound force. So this is that force. Okay, and this will serve as your resultant. So we're going to solve, okay, for its component forces, which is along the cables AB and cable AC. Those are the component forces that we have to solve. Okay, so there's a given alpha here, which is 55 degrees, and beta, which is 30 degrees. So let's start solving this. So let's first list down the things that are being asked here in the problem, okay, which are the component forces AB and component force AC. Okay, so the given again is the 360-pound force, which will serve as our resultant, and then the angle alpha, which is 55 degrees, and your angle beta, which is 30 degrees. So using triangle law to solve this, we have to form first a triangle. So we already have a resultant. So knowing that your resultant is this force, let's say this is your 360-pound resultant. Okay, so you have to draw, let's say, your AB. Okay, so this will be your component force AB. So we can draw it this way. Okay, so this will be your force AB. Now, after drawing that, you can also draw your force AC, your component force AC this way. Okay, so this will be your force AC. Now, as you can see, they don't actually meet, right? So we can actually extend the line of action of this force and this force, or the okay, so that they can meet here, and that so that they can form a triangle. So we can do that. We can extend the line of action of forces to form a triangle. So now this will now be our triangle. So analyzing our triangle, okay, so your AB is this, right? So from the vertical, okay, your AB is 55 degrees. So meaning to say your AB from the vertical here, this will also be 55 degrees, right? And also your AC, okay, from from here, okay, from the vertical, okay, this is beta, that is 30 degrees. So it should also be 30 degrees from the vertical here. So your AC should also be 30 degrees from your vertical here in your triangle. So since this is 55 degrees and this is 30 degrees, we can solve for the remaining angle, which is just equal to 180 degrees minus 55 degrees minus 30 degrees, and that will give you 95 degrees. So now, this will now be the data, okay, of our triangle. We have here 360 pound side. Okay, we have here 55 degrees angle. We have here 95 degrees, and we have here 30 degrees. So as you can see here, we have complete data for angles, right? So for this available data, we can use sine law. So using sine law to solve for AB and AC, so let's first solve AB. So let us use the sine law. So 360 degrees is the available side, okay, over the sine of the angle opposite to that side, which is 95 degrees. So you write 95 degrees equal to the side that you want to solve, which is AB. So that will be AB over sine of the angle opposite to that side, which is 30 degrees. So you write sine 30 degrees. So solving for AB, so you just cross multiply this. So sine 30 times 360, this will be the new equation over sine 95 degrees. So inputting this in your calculator to solve for the value of AB, so that will be 360 sine 30 degrees over sine 95 degrees. That will give you 180.69. Okay, so all again, don't forget to put the unit. So the unit for this is pound. So you put pound here. So the answer for AB will be 180.69 pound. Now we should also solve for AC. So using again sine law for this. So 360 over sine 95 degrees will just be equal to the side that you want to solve. That will be AC over the opposite angle opposite to that side, which is 55 degrees. So that will be sine 55 degrees. So solving this, cross multiplying this will become 360 times sine 55, okay, over sine 95. So that will give you, so let's input that in your calculator. That will be 360 times sine 55 over over sine of 95. So that will give you 296.02 pounds. So that will now be the answer for this problem. So that concludes this session. I hope you learned. So see to it that you have learned the intended learning outcomes for this topic. And also don't forget to answer the assessment task in the latter part of the course material uploaded. So study well, keep safe, and God bless.